Well, good morning, guys. This is Brett coming to you from Washington State. This is the NISA Virtual Science and Engineering Fairs Design Challenges. We have 4 of them coming up. The first one we're going to do is called What Floats Your Boat. You'll have access to this folder in the website, in the Google site that has been developed. So here's the Google site. Now, here is the design challenge itself. When you complete the design challenge, you will navigate to the design challenge resultant page. On the resultant page, you will put your successes. For this one, it would be the first boat that they built and the test that carried the most mass. The next one would be your best analysis of the device. The next would be the best redesign and the evaluation and redesign. So you'll be the judge of that, and you can just put in the document here with a link and make sure that all the FERPA and GDPR stuff are removed so the students have anonymity and they can then see the results. And then at the end of this, we'll go over it. Now, without further ado, here is the first design challenge. What floats your boat? Well, we start up here at the top. I wanted to focus on the 5th stage of the engineering process because my students do it the most poorly. They don't do a test and then evaluate that test and redesign their model using that testing data. So what we're going to do is we're going to force them to do it with this process. So the first thing they've got to do is you give them a 15 centimeter by 15 centimeter piece of aluminum foil. They're going to design a boat that's going to carry more than 250 grams. And that's a bit of a challenge, just so you know. It has to stay afloat for more than 5 seconds. And that is pretty much their initial stage of the process. So you give them the 15 centimeter piece of aluminum foil. Now they've got to think and design a boat that's going to carry 250 grams. When they're done with that, they're going to draw a picture of it, label all the dimensions of it, so they know it, and then they're going to build that boat. And then with that, they need to record the volume of the boat. And how they calculate that, if it's a rectangle, it's length times width times height. Straightforward, simple. Pretty easy to do. Now, if the boat is not rectangular, you need to either decide, is it more circular, more triangular, more trapezoidal? And then you decide, is the base that shape, or is the end that shape? If it's the base, you multiply it by the height. If it is the end, you multiply it by the length times the area of one of those shapes to get the volume. Now, you'll put the calculation here, and then you get to test your boat. And then the kids will test their boats, drop in the coins, and record it, and report back to you guys what they say. Now, my students are not the best measurers, so you've got to be really on it to maybe come up with a way to get really good measurements. My students weren't real honest with their measurement or weren't real accurate with their measurement. My kids, that's normal. Students have trouble measurement. So they're going to put in their name, their shape, length, width, and height, and then the total volume of their design, and then what the total mass is carried. They'll report that to you. Everybody will fill in the sheet below, and they will all have the design from all the kids in the class and what their boat design was and what it carried. And that's pretty much the process. Now, when they're done with that, they're going to go to Google Sheets, copy and paste it into a Google Sheet. And that's where we're going to start to do this, which is develop graphs. Now, we'll get down here to class data. Get rid of that. Oh, delete. Okay. Now, up here, you're going to paste all this material into the spreadsheet. And I'm going to teach you how to sort range, header columns. I'm going to do it by shape to start. Boom. And sort. Okay. Now, this is where we kind of started this. What I'm going to do is I want to sort this data. I'm going to get rid of this data. row start, delete that row, done. Now, to sort data, your best thing that you want to do is sort range. And in this case, I want header rows. I want to do it by shape, but because the canoe and the circular, I'm going to reverse order that. And then I want to go, after that, I want to go smallest to largest for volume and sort that. Now, I have a data table sorted. I can generate a graph from this. And what I'll do is I will sort by volume. And now this gives it to me pretty straightforward. What I want to do now is I want to get this data down here to look better. So I'm going to go over here to Customize. And I'm going to go to Series. And I don't want to apply it to all series. I want to apply it to this one. And I want to add a right axis. And I want to add it to this one. And I want to make that a right axis. And I want to add it to this one. And I want to add that the right axis. And the reason I want to do that, now we've got something. Okay. What we've got here is volume. We've got heights. And we have lengths. Let's get rid of everything but the heights and the volumes. So go back to setup, and we're going to remove some data. So we're going to remove that and remove that. Now we've got height. Now go back to Customize in Series. Let's move that to the left axis this time. There we go. Now our heights go from 4 to about 1.5. And our volumes go from just shy of 250 to others. Now, something you can do to the graph to make it more interesting is, let's go back to series again. Let's talk about your volumes, because the volume is really the critical thing here. Let's have some data labels. Add some data labels. Okay, we've added data labels. And what I want to do next is put a title on this. And I would say volumes versus heights of rectangular boats. Now, that's a way to start, and then the kids can take this data and use that to analyze their information. Now, if they get sophisticated with it, they could also design their own data tables and do modeling with just the graphs. So that's what I've done. Now, they want to manipulate their data and look at it in different ways, maybe change the axis, maybe change stuff up and down, maybe use a line graph. But I'm going to show you what I did. What I did was I took different shapes and modeled some things about them. So I took a rectangular boat, and I did that with a change in length and width and height. So if I change the length and the width, and then I just built a table. Now when you do that, you'll notice you can get a 250-gram boat. Now I also did that for a circular model boat. Now the radius is, so it's pi r squared times the height, and the height would get bigger. And as it gets bigger around, it gets shorter in height. So you could graph both those changes and develop this one. This one carried about 118 grams. And then there was the one that kind of led me to think, this is interesting. what happens if I take my boat that's rectangular and then pitch out the sides? Well, that changes it, and I did it just off of one side of the trapezoid, and that gave me 275 grams. Now, if I do both sides, it seems pretty logical that I could add another 25 milliliters, and that would push me close to 300 grams. Now, that's analysis that our students could possibly do. So that's the level it can get to. Now, if they really wanted to, they could actually use calculus to do that. But I just used algebraic manipulation of the graph and did it myself. Now, you put that back into your graph, your data here. You then give 6 bulleted analysis statements about the graph, and you can put labels and stuff. Now, when you put a graph in a Google document from a Google spreadsheet, so let's go here, let's copy, I like this graph right here, so I want to copy. So I'm going to copy that. Now I'm going to go back to here. I'm going to go here. Now, the thing you don't want to do, and the best thing to do, is you go to insert up here, and you don't insert the graph normally. You do it as a drawing. Make a new one. And the reason you do that, because then I paste it unlinked because I don't want to change the data at all. Now you can put in things like arrows. And you can use arrows and labels and text boxes to point out information that here the da-da-da-da-da. And then you save and close. And then you have a labeled and points to put in your points for your data analysis. And that's really sophisticated for kids to do. Now, things that they could do right, so you've got an axis that's labeled with appropriate units. You have subtitles. There's all sorts of stuff you can do. You can have multiple axes. And in Google Sheets, it's very, very, very comprehensive. But that's what we're trying to get them to do, is analyze their things. From those analysis statements, that's going to lead them into their new design. And now they're going to redesign their boat that they built from before and try and make it even better than it was before. Now, you list the reasons here with the evidence from your data above, and then you get to test it again and see, hey, did it really work? And that's as brief and quickly as you can do this. You can do this in about 2 to 3 class periods. And that is all. Thank you for joining us, and remember to post your results here with your Google documents, and have a great day.